Okay, now we will start with the chapter 3. Chapter 3 talk about kinematics. In kinematics, we will talk about speed, displacement, velocity, and acceleration. First of all, you have to remember the speed of something like light. You have to remember that the speed of light in air or vacuum, it's 3 times 10 to the power 8 meters per second. And the speed of sprinter is about 10 meters per second. If anyone try to walk, then his speed is about 1.5 meters per second. So you have to remember these values. What is the meaning of speed and velocity? And what is the difference between speed and velocity? Speed and velocity, we use simple V to talk about it. We have speed, which is scalar, and we have velocity, which is vector. The scalar quantity have magnitude only, as I mentioned before. The vector quantity has magnitude and direction. Now, speed equal distance over time, while velocity it's equal displacement over time. Displacement is vector, distance is scalar. Some books put an arrow upper the simple V to denote the velocity, or some book write V in a bold letter to distinguish between scalar, which is speed, and vector, which is velocity. In this year, we will continue using V as it is, but you have to know, is it displacement or distance, to recognize is it scalar or vector. Now, the average speed, it is the distance moved over time taken, and its unit is meter per second, okay, or kilometer per hour. How to change the unit from kilometer per hour to meters per second? You have to multiply the value by 1000 to change from kilometer to meter, and divide by 60 times 60, which is 3600, to change hour to second. So, to change from kilometer per hour to meters per second, we have to multiply by 1000 over 3600. To change from meters per second to kilometers per hour, you multiplied by 3060 over 1000, the inverse of this value. If you ask to write the definition of the average speed, you can write it is the distance moved per time taken, or the rate of change of distance, okay? And velocity, it is the rate of change in displacement. Rate, it means per unit time. No need to write it is the rate of change in displacement per unit time, because in this way you put time twice. You just write rate of change in displacement, okay? And that's all. Now, the average velocity, as I mentioned, it is the displacement over time taken. Now, if we have a relation between distance in meter and time in second, so we can find the speed using the gradient. Gradient, it is the change in y values over the change in time, or the change in distance over change in time. Okay? When you wanted to find the gradient, take 2 points in the line and use the good points, and you have to show the examiner which points you choose to find the gradient, and you have to take 2 points which are away from each other. If the line not straight like the one drawn up, you can take the tangent at any point. If you want to find the speed here, you just write the tangent or draw the tangent and find the gradient. And here the same, you draw a tangent and find the gradient. Now, what is the meaning of instantaneous speed? Instantaneous speed is the speed at definite point in a short time period, okay? That means if there is a car moving from point A to point B, and you want to find the instantaneous speed, it is the speed at this point, let's say C. This is the instantaneous speed. So it is the speed at a definite point. Now, from displacement time graph, we can find the value of the velocity. Now, we have many graphs that you have to remember. Let's start by displacement time graphs. Usually, we put time on the x-axis and the displacement in the x-axis. Displacement sometimes denoted by S, sometimes denoted by D. But it's better to denote it by S to recognize it from the other. Okay, now, if the relation between displacement and time, starting from 0, a straight line like this, and maybe it is a straight line like this, or maybe a straight line starting from the origin and moving up, or like this curve, or like this curve. We have many types of graphs. These are the most used figures. Here you can see that the time is running, but the position is stay 0. So this object is stationary. It's not moving. So the velocity equal 0. Let's see second figure. Here the displacement, let's say 10 meter, and the time is running, but the object stays at the same point. This means that the object is stationary, but not at the same place. Let's say you go to school and the bus is parking outside and the bus stays at its position. So the bus moves for 10 meters at the beginning, let's say, and it stays there. So it's another type of stationary object. What if the displacement and time increases like this figure? So the object moves by constant speed, and you can, or constant velocity if it is displacement against time. You can find the gradient, take 2 points, and show what points you take. This is y2, y1, x1, x2. So the gradient of this line is the velocity of this object. If the curve is moving down like this figure, now the speed is not constant. So here we have a value for speed. Let's say v1, find the gradient at this point for this line. and you can find the gradient of this line here, v2. So v2 less than v1, so the speed or velocity decreases. Okay, here tangent, here another tangent. Okay, so v2 larger than v1, the speed is moving up, so the object moving by increasing speed, the object is accelerating. Okay, so these are the 5 types of speed of displacement time graph and the different value of the speed. Okay, now, so the most important from displacement time graph is to find velocity, okay, which is the gradient of the line. What about the velocity time graph? Velocity time graph, you can calculate the average acceleration or the acceleration, which is the change in velocity per unit time, or it is the rate of change of velocity. So the acceleration is the rate of change of velocity. I can draw another 5 figures for velocity time graphs, and let's see what is the difference. This is velocity, meter per second, and here the time. Another one, and another 2 here. Okay, now first one is like this, and this is the other one, and here another one here, and another one here. Okay, now in the first one, if you wanted to find something, you can say that the object is stationary. Stationary object, so velocity equals 0. No change in velocity, so acceleration is 0. The other one, the velocity is constant. The velocity is constant because the time is running and velocity stays the same, meters per second. Now, velocity is constant, so the acceleration is equal to 0 because there is no change in velocity. Figure 3 here, velocity against the time. Here, the acceleration is constant also, but it's have a value. It's not 0. It is the gradient of this line, v2 minus v1 over t2 minus t1. Okay, so here we have positive acceleration, which is constant acceleration. For this graph here, you can see that the speed is increasing, okay, but not in the same rate as this figure. So we have here acceleration, which is the gradient at this point, and if we take another point and find the gradient, we can find that the acceleration in point 2 is less than at point 1, so acceleration decreases. In the last figure, the acceleration is increasing. Now, so we have displacement time and we have velocity time. The difference that in displacement time, a gradient is velocity. In velocity time, a gradient is acceleration. Okay? In velocity time, we have another importance for it, that I can find the area under the curve, which is the displacement. Okay, so the velocity time graph can give you more information about the object or about the movement of the object. Let's see. If we have velocity time graph like this and the object movement like this, so if you ask to find the acceleration, it is just a gradient, y2 minus y1. If you want to find the displacement, you find the area here, which is equal to area of a triangle, half base height. and its unit is meter or centimeter, depending on the unit of velocity. So the area under the line or area under the curve equal to the displacement travel. This is the area, okay? If you ask to find the displacement till this point, you just take this area only, not all the area. Okay. What if the curve starts in the positive x-axis and then continue in the negative x-axis? So we have displacement here, displacement 1, and we have displacement 2. The displacement in the upper part is positively value, and the displacement down is negative value. So the total displacement, you add up d1 by d2 using the signs with the values. Okay? Why? Because here the object moves in the opposite direction. So the acceleration, it is the change in velocity per unit time or rate change of velocity per unit time. Now, not all the time the acceleration is constant. Sometimes the acceleration is not uniform, like the last example. Now, what if the acceleration constant? If the acceleration constant, you can use equations of motion. Equations of motion is very important in mechanics and in physics. We have 5 equations, which are V equals U plus AT, it is the first one. U, it is the initial speed. V, final speed. A is the acceleration, and T is the time. This equation is known very well for us, which is V minus U over T. We multiplied A by T, which is equal V minus U. So V equals U plus AT. This is the first equation of motion. We have another equation, which is V squared equal U squared plus 2AS. S is the displacement. S is the displacement, okay? Now, we can use one of these equations to find the value for acceleration or other value. Okay, now we have S equal ut plus half at squared, which is a third equation. S is the displacement, u is the initial speed, acceleration is a, and t is the time of the movement of the object. So v equals u plus at, this is first equation. S equal ut plus half at squared, this is the second equation. V squared equal u squared plus 2as, it is the third equation. We have another two equations, which are S equal vt minus half at squared, and the last one S equal the average velocity, which is u plus v over 2 multiplied by t. These are the 5 equations for motion, which is very important, and you have to remember that this equation can be used only if the acceleration of the object is constant. Okay, these equations only can be used if the acceleration uniform or acceleration is constant. Most of the students use speed equals distance over time in a wrong way. So you haven't to use speed equals distance over time unless the speed is constant. Okay? Now, let's try to see an example like this. Sport car accelerate along a straight track from 70 kilometers per hour in 6.3 seconds. You can see that the units are not the same. So you have to change kilometer to meter and hour to seconds. What is its average acceleration? Acceleration, it is the change in velocity per unit time. It's a start from rest. Rest means that the initial speed, which is u, is 0, and this is the final speed v. So the acceleration equal v minus u over t. This is v, 70, multiplied by 1000 over 3600. In this way I can find the value of v. U is 0, and this is the time of the object.